Hello, Algebra 2 students. I appreciate you finding time to get your notes taken care of. Today we're going to be taking the next step in the usual progression that we've been looking at, going through these units, which would be to take a peek at the inequalities and the logarithmic function. So please copy the title, Inequalities and the Logarithmic Function, as well as the objective for this day, which is to learn to determine how an inequality affects the solution set for a logarithmic function. Okay, so let's take a look. A lot of this is going to feel very, very familiar. It's not like a lot is changing as we move through these different types of parent functions. Okay, so let's take a look at a typical logarithmic function. Here we have log base 2 of x plus 3 plus 1. Now the same information continues to apply. Any point x comma y that exists on this curve is a solution. So I graphed it, took a little screenshot of it there for you. That's what the graph of log base 2 of x plus 3 plus 1 looks like, and I've marked 4 particular points on it for no particular reason. Any point x comma y that exists on that graph is a solution for that graph. Doesn't matter if they're positive or negative or whole numbers or fractions or rational or irrational decimal points. Any point that you can find on there will plug in for x and y into the original equation and will balance that equation. Okay, so of course there are many more points that are available to us other than these 4. That was just 4 representative points that I happened to pick. Okay. When the problem becomes an inequality rather than an equality, we find even more solutions than we had before. Okay. Now I see my file has picked up a little glitch here. Guys, the little box that is around the less than or equal to sign, I've noticed sometimes my files do this, and some of you have been actually drawing the box in on your notes, which just kind of proves that you haven't been paying any attention. That box is a glitch in the file. It's not part of the notes. Okay, so the fact that y'all have been copying it down, have not understood what it was, haven't been asking what it was, just kind of proves we're not paying much attention. We're just copying the notes because somebody is making you copy the notes, but you might actually want to start listening, paying attention. That red box actually shouldn't be there. It's a glitch in the file. I need to get it out of there. Okay, but anyway, y is less than or equal to log base 2 of x plus 3 plus 1. Same curve. The curve is still part of the solution set because we have an equal inequality. Okay, but also every value of y that exists under the curve is also a part of the solution set. So any x comma y that's in that shaded area will yield a true inequality when you plug that x comma y into the inequality. And the reason it's shaded downwards is because the inequality says so. It says y is smaller than this curve. Well, the smaller values of y are downward from the curve, as always. Okay, now same drill. This ought to be sounding very, very old and very familiar to you. Okay, same ways to manage inequalities still apply. If a variable is already isolated, you can simply shade in the direction of that axis according to which way the inequality is positioned. So as always, if it says y is smaller than the curve, then you shade toward the smaller values of y. That's downwards. If it says y is greater than the curve, then you shade towards the bigger values of y, upwards. Okay, if it happens to be inversed and it says x is smaller than the curve, then you shade towards the small values of x, that's to the left. If it says x is larger than the curve, then you shade toward the bigger values of x, and that's off to the right, as always. Okay, so if you're looking at a couple of curves, just a couple of examples here in case you haven't quite figured it out yet, let's take a look. On the left side, y is greater than or equal to the negative of log base 3 of x plus 3 minus 4. Okay, so the graph is already drawn for us. Just a few things that we know. Of course, the graph, the center of the graph or the starting point of the graph has been moved -3 units. Actually, I've got my graph positioned incorrectly. Sorry about that. The graph should be moved 3 units to the left and 4 units down. I actually have it moved 1 step too far to the left because it should have been from the starting point 1, 0. But anyway, since the inequality says y is greater than or equal to, okay, we have a solid line because of the equal to, and y is greater, so we shade everything that is above the curve, because it said y is greater than. So anything that's on the line or anything that is in the red shaded area, any x comma y, should plug into that equation, that inequality, and should make a true statement. Over on the other side, I've got the graph positioned incorrectly again. I did a bad job here. Our graph should be moved 4 steps to the right and 3 steps up, but once again, that should be from the location -1 on the x-axis because the graph is backwards, has a negative x value. Okay, so I've got my graph positioned incorrectly. Let's see if we can get the shading right anyway. Okay, y is less than, okay, the curve, then we go towards the smaller values for y. So everything that is downward from the curve should be shaded. So anything on the line or in the red shaded area, any coordinate x comma y should plug into the inequality and give you a true statement. Okay. Now here's where the tests have been going when they do ask us the question. Typically they have not had the variable isolated, but it has not been a big chore. Okay, so if the variable's not isolated and you can isolate it wherever it's possible or practical, a lot of times here lately when they have asked the question, they've had something attached to y. So you've had like y plus 2 or y minus 3 or something like that. Be sure to move anything that may be over there hassling the y value. Move it away from y before you try to make any decisions about shading, because it is possible that some of the changes could actually reverse the direction of the inequality, and that would make you shade the wrong direction. Okay. And the kind of fail-safe situation that we have here is for any inequality, any time, any graph that you happen to encounter. If you're trying to decide which direction to shade, you may pick a coordinate, an open space, okay, something that is not on the line. Typically try to stay near it, but stay off of it, okay? Something that is not on the line, nearby. Plug it in and see if the inequality likes it. If it gives you a true statement, then that means that the inequality does like that point, so shade towards that point. If the inequality gives you a false statement, then it did not like that point, so shade away from it. Okay, so let's look at some basic examples here. This ought to be getting to be old news. You've seen this several times and shouldn't be a big deal. Graph the solutions for y is less than log base 2 of x plus 3 minus 2. Okay, let's see if I get my graph positioned correctly this time. Okay, we need a starting point to begin our graph from. Remember that the logarithmic curve wants to cross the x-axis at +1 unless the graph is backwards. The only thing that can make the graph backwards is a negative x value. We do not have a negative x value right there, so we do not have to worry about a backwards graph. It wants to cross right there. Okay, but h and k are moving it. They're not allowing it to cross where it would like. Okay, so let's look at h and k. Well, here's our h value. It should say minus some number, but it says plus. That means our number must be a negative value also. So we should be moved 3 units in the negative direction. So we should come 3 steps to the left. And then our k value is supposed to be positive, but it is negative. That means the 2 is negative, so we should drop 2 steps down. So if I've done this correctly, our starting point should be at -2, -2. And yay, I did actually get this one correct. Okay, so we've got a starting point of -2, -2, and we can, of course, plot that in our grid. Okay. Now from there, we need to decide some points moving each direction away from this starting location. Now, remember that the parent function, as you leave this starting point going to the left, that is typically the vertical side of the graph. So those would be the baby steps. And going to the right, that's the horizontal side of the graph. So those would be the larger steps. And the only thing that can turn the graph around backwards would be a negative x value. Well, we already said we don't have that. Okay, so moving to the left of this location, we want to pick baby steps. And moving to the right, we want to pick bigger steps. Okay, so there are some reasonable values to pick. Okay, sorry about my 4 in the denominator there. It looks like it's completely shrunken down to a tiny little speck, but it should say 2 3/4. Okay, so how do you get the y values that go with this? Well, of course, once you get this typed into your calculator one time, all you have to do is plug in your x value and then hit second entry over and over again and just keep replacing the different x values. For every x value you plug in, you're going to get a y value to go with it. Okay, so we should be looking at values coming back out of our calculator that look like these guys. So of course, once your chart is filled in, you've got a bunch of ordered pairs. Once you've got your ordered pairs, you have points in your graph. And once you have points in your graph, you can connect the dots. But of course, we want to make sure that we get our dots connected correctly, which is not to say that connecting the dots is so hard, but we need to make sure that we get the right style of line. Remember, with inequalities, we can have solid lines, we can have dashed lines, and we need to make sure we get the right choice. Okay, so what do we want in this case, a solid line or a dashed line? In this case, the line should be dashed because of um, the fact that our inequality is a non-equal inequality. So this green line that has shown up, it is the boundary for the problem, but any point that exists on it, including the yellow points that we have marked on it, they are not solutions for this problem set. Any x comma y that you plug in that is on that line, the inequality is not going to like it. However, we should have some area shaded around this curve that will be part of the solution. Okay, so let's take a look at where that's going to be. The problem says y is smaller than this equation. So y is smaller than this curve. Where are the smaller values for y? They are downwards from the curve. So we should shade in everything that exists underneath this curve, but not the curve itself. Okay, let's look at one more real quick. Graph the solutions for y is greater than log base 1/2 of negative x plus 2 minus 1. As always, the best thing that you can start off with in a graph is a starting point. Okay, so let's see if we can't figure out where this graph is supposed to begin. Okay, now examining the equation, a couple of things I see here. First off, we have a base number for our logarithm that is smaller than 1. It's in between 0 and 1 on the number line. Now that does cause an effect change to the graph. Okay, but remember that with the logarithmic function having a base number between 0 and 1, that actually turns the graph upside down. It's kind of the same effect as having a negative y. Okay, so it's still going to try to cross the x-axis at positive 1 with the base number being smaller than 1. Okay. However, looking at the argument, I see a negative x value. Okay, well that's going to change the graph. Negative x is going to reflect the graph through the y-axis. So it's going to turn our graph around backwards, including our starting point. So our starting point, instead of wanting to be at 1 on the x-axis, that negative x is going to cause it to want to be at negative 1 on the x-axis. Okay, so our x values from there are adjusting. Here we have a h value of 2. Now remember, when the negative value is in front of the x, that causes this h to read exactly the way it is written. So that actually is a positive 2. So it's going to move it 2 units to the right. And then we have a k value of negative 1. That will drop it down 1 unit. Okay, so if I've got it correct in my notes here, it looks like we should be at +1, -1 for our starting point, and I did get it correct. So there it is, +1, -1. Since we have that point, we can mark it in the graph. Okay, now let's figure out which direction we are moving, or the step sizes, okay, from there. Okay, now we've already said that the graph is backwards because of the negative sign in front of the x. That means that instead of being vertical to the left and horizontal to the right, that is going to be reversed. We're going to be horizontal to the left, vertical to the right. So we're going to take big steps moving from 1 on the x-axis to the left and smaller steps moving to the right on the x-axis from 1. Okay. Again, my fractions are kind of messed up for some reason. My file is not translating very well from one computer at home to the computer at school. Okay, but there it is. 1 1/4, 1 1/2, 1 3/4. Okay, and bigger steps moving to the left. Once again, once you get this equation in your calculator one time, then all you have to do is keep hitting second entry and replacing the x value each time, so it's not too big of a chore. Okay, and you end up with some decimal points. Okay, then you've got your ordered pairs. Your ordered pairs become points in the graph. Now it's time to connect the dots. Okay, so before you connect the dots with an inequality, you need to ask yourself, what type of connection do I want? Do I need a solid line or a dashed line or what? So take a look back at the inequality again. We see that once again this time we have a non-equal inequality. So that means once again we will have a dashed line connecting our dots. So again, any point that exists on this line is a boundary for where the solutions are, but the line is not a solution itself, including all of these points that you have in your chart and are marked on the chart or on the graph. They are not going to make that inequality work. Okay. But anyway, looking at the equation, the inequality again, it says that y is greater than this equation. So y is greater than this curve. Where are the values of y bigger? They are bigger going upwards from the curve. So we should shade everything that is going upward from the curve like so. Okay, so anything in the red shaded area, x comma y is out of there, they are good and they will make the inequality work. Anything that is on the green dotted line or not in the shaded area is not going to make the inequality work. Okay, so it's pretty basic. It ought to have the same feel that it's been having for the last several months as we've moved through these. Anyway, I appreciate you finding time to get your notes taken care of, and I will see you in class.